We want to find all real numbers on the interval from 0 to 2 pi that satisfy this equation. In looking at this equation, I see I've got a sine squared x, and then I have a sine that's not squared, but the angle, the argument, is 2x. I don't want them different, so I'm going to think about, is there an identity that I can use so that I can get them in terms of the same argument? And there is. I could leave the sine squared in terms of x, and on the other side I could use the double angle identity for sine 2x, which was 2 sine x cosine x. Now that I have them in terms of the same angle, I think I'm going to move everything on one side equals 0 and see if I can factor this. So minus 2 sine x cosine x equals 0. Now I see that there's a sine x in each term, so I'm going to take the sine x and factor it out in front. That would leave me a sine x minus 2 cosine x equals 0. Now that I have it factored, I'm going to set the first factor equal to 0 and solve it. Sine x equals 0. And I need to think of when is the sine 0 on one loop around the circle, 0 to 2 pi. And the sine is 0 at 0 and at pi. Now I'm going to take the other factor and put it equal to 0. See if what I can do with it. 2 cosine x equals 0. So I've got both a sine x and a cosine x, and they're not squared so that I could use like a Pythagorean identity. So I'm going to move the cosine term to the other side. Sine x equal 2 cosine x, and then I'm going to divide both sides by cosine x. Whoops, cosine x. So that'll be gone from that side, and that'll put over on this side, and so I'm going to rewrite the sine over cosine as tangent. So I've got tangent x equal 2. Now this isn't a unit circle value, so if I'm not told to use a calculator and approximate, then I should express this like you did on the homework in exact form. And so I'm going to have, if I take the inverse tangent or arctangent of both sides, then I can solve it for x, and I would have arctan of 2. That would be my first solution. Let me write this over here. So I have tan x equal 2, and then I take the arctan, and that will undo the tangent and leave us x, and then I have the arctan over here on the 2. Okay, so there's my first answer from that. And if we think about tangent, when we're talking about arctangent, and we think of the unit circle here, arctan of 2, I would be up here in quadrant 1, and where else would I have a tangent that's positive? And that would be around here in quadrant 3. So we will get another answer, and I'll put it just down below. We would get another answer if we add pi to the arctan of 2. So we would get around there into quadrant 3.